The last shape that we're going to talk about in chapter 5 is a trapezoid. And the only thing special that you can say about a trapezoid is that it's a quadrilateral with exactly one pair of sides that are parallel. Okay, so again, in the picture below, we can see that MN is parallel to LQ. And besides the fact that it has 4 sides, that is the only thing special that we can say about it. If we end up making it an isosceles trapezoid, we can say a little bit more about that trapezoid. Okay, an isosceles trapezoid would be directly related to an isosceles triangle. Remember, base angles of an isosceles triangle are congruent, and that's what's going to happen in a isosceles trapezoid. And an isosceles triangle, 2 sides are congruent, and the same thing's going to happen in an isosceles trapezoid. Your legs are going to be congruent. Okay, so if you have an isosceles trapezoid, again, you're still going to be able to say that your one pair of sides, opposite sides, is parallel, and you're going to be able to say that your non-parallel sides, which are called legs, are going to be congruent. So AD would be congruent to BC. And then your base angles, again, you can see in the picture on the right, your base is your pair of sides that's parallel, so your base angles are going to be congruent. So D will be congruent to C, and angle A will be congruent to angle B. Okay, so pretty much that's exactly what I was just saying is what's written down here. Properties of your isosceles trapezoid: only one pair of opposite sides are parallel. The 2 non-parallel sides are the sides that are congruent, and again, they're called legs, and the base angles are congruent. And also only in an isosceles trapezoid, not in a regular trapezoid, you can also say that the diagonals are congruent. So if I drew in the diagonals there, I can tell you that DB is congruent to AC. It's the only thing special I can say about those diagonals. They don't bisect each other. They don't intersect to form right angles. There's nothing else special about them besides the fact that they're congruent. So here's our examples for our regular old trapezoid. We want to find the measure of angle M and the measure of angle K in trapezoid JKLM. Okay, so what's going to happen here is that M and J, these 2 angles right here, are going to be interior angles on the same side of the transversal. Remember, these 2 pairs of sides are parallel, which makes this a transversal, and it makes these 2 angles interior angles on the same side of the transversal. And from way back when, interior angles on the same side of the transversal are supplementary. So if I take my 180 and subtract out the 87 that I used for that one angle, that's going to make the measure of angle M 93. Okay, so 93 is going to be the measure of angle M. Okay, and on the other one, we want to find the measure of angle K, and the same thing is going to happen on the opposite side. I'll change colors. Again, we're still going to have our pair of parallel lines, but this time, this is my transversal, which is going to make the angle marked 51 and angle K supplementary. So again, if I take my 180 and subtract out 51, because again, interior angles on the same side of the transversal are supplementary, I'll end up with an answer of 129. So 129 is going to equal the measure of angle K. So for number 2, we want to find the value of X. Pretty much the same process that we just did in the problem before, except again, now we have X values in here. It's not just a straight number. Okay, Q and R, again, parallel lines cut by a transversal. These 2 angles are interior angles on the same side of the transversal, and interior angles on the same side of the transversal are supplementary. They add to 180. So we're going to do 12x plus 3 plus 7x minus 13, and that's going to equal 180. Okay, 12x plus 7x is going to give me an answer of 19x, and a positive 3 and a negative 13 will give me an answer of negative 10, and that's going to equal 180. Next, I'll add 10 to both sides, and 19x is going to equal 190. Divide both sides by 19, and x is going to equal 10. It only asked me to find the value of x. I found it. I'm done. Hey, now let's switch to an isosceles trapezoid. So now if trapezoid CDEF is isosceles, we want to find the measure of angle F here in the end. So again, we need to be careful. Again, I'm only given something about angle C and angle D, and because this figure is a isosceles trapezoid, that means that those two angles are going to be equal. So the first thing I'm going to do is I'm going to set them equal to each other to solve for x. So I'm going to have 21x minus 16 equals 18x plus 5. I'll subtract 18x from both sides first. Have 3x minus 16 equals 5. Add 16 to both sides, and 3x is going to equal 21. The opposite of multiplying by 3 is to divide by 3, and x is going to equal 7. Again, it's not asking me to find x, it's asking me to find the measure of angle F. Okay, now, in order to do that, the first thing I'm going to have to do is I'm going to find the measure of angle C. Once I find the measure of angle C, again, those two sides are parallel. You have it being cut by a transversal. These will be interior angles on the same side of the transversal, and they'll be supplementary. So first, let's find angle C. So angle C is 21x minus 16. Again, we just found out x was 7. So we're going to do 21 times 7 minus 16. 21 times 7 is 147. 147 minus 16 should give you an answer of 131. So 131 represents the measure of angle C. Again, I don't want angle C, I want angle F. Again, C and F are interior angles on the same side of the transversal, so they're going to be supplementary. So if I take my 180 and subtract out the 131 that I got for angle C, that will leave me with an answer of 49. So angle F is going to be 49. Hey, again, always go back, reread the problem, and make sure that you actually answer what they were asking you to find. Hey, mid-segment. Hey, a mid-segment of a trapezoid is the segment that joins the midpoints of its legs. So again, if this were a midpoint and this were a midpoint, that's why this is marked congruent to this, and that's congruent to that. And again, this is called a mid-segment. Okay, so what the deal is here, a mid-segment theorem for a trapezoid is that if EF is the mid-segment of the trapezoid, then AB is parallel to DC, which is parallel to EF. So all three of those lines are all going to be parallel. And then the other thing that you can say is that if you take AB and you add DC to it, and then you divide by 2, that will give you the measure of that mid-segment there, EF. Okay, so we have in trapezoid ABCD, EF is the, that should say mid-segment, is the mid-segment. Okay, and if AB is 23 and CD is 12, we want to find the length of EF. So again, if I take this side plus this side and divide it by 2, that's going to give me that side. So 12 plus 23 divided by 2. 12 plus 23 will give me an answer of 35. And 35 divided by 2 will give me an answer of 17.5. Okay, and number 5, the last problem for today, we want to find GH in that trapezoid. So again, this is GH. And again, I know that GH is a mid-segment. Why? Because again, you have these hash marks showing that they're marked congruent. So again, if I take CD and add FE to it and divide by 2, it's going to have to give me back this 3x minus 6. So we'll do 2x minus 1 plus 25, divide that all by 2, and when I do that, again, I have to get the mid-segment, which is 3x minus 6. So I'll simplify on the top first. Negative 1 plus 25 is a positive 24. over 2 equals 3x minus 6. I think the easiest way to see this one, you can multiply both sides by 2, but for some reason I don't think you guys like that one, but I think you like this one. Put this side over 1. Now you have two fractions that equal to each other, and you can cross multiply. So you're going to have 2 times 3x minus 6. 1 times anything will just be itself. So that's going to equal 2x plus 24. We'll distribute that 2 through. So I'll have 6x minus 12 equals 2x plus 24. Subtract 2x from both sides, and I'll have 4x minus 12 equals 24. Opposite of subtracting 12 is to add 12, and I'll have 4x equals 36. Opposite of multiplying by 4 is to divide by 4, and x is going to equal 9. Again, it's not asking me to find x here. It's asking me to find GH. And again, GH is the one that's represented by 3x minus 6. Again, we just found x was 9. So if we do 3 times 9 minus 6, I'm going to have 27 minus 6, which is 21. So 21 is your final answer there. And that is the end of this video.